So today our section is 2.1.3 and we're going to work on graphing some parabolas. So far when it came to graphing parabolas or graphing anything, I guess, we've either been like using our graphing calculators or trying to create a table and then plotting those points and then being able to make our graph. So we want to be able to, when it comes to our quadratics, to make it a little bit more time effective, is to come up with some patterns that we see and what these different equations mean when it comes to graphing it, so we can just look at the equation or maybe just do a little bit with the equation to sit there and try and figure out how to graph our little parabolas. Because who knows, we could have a non-calculator quiz, right, of where you have to graph by hand and not using a calculator or Desmos type thing. Oh, I might. Alrighty. So one form, it depends on, they either call it graphing form or vertex form. So I'm just going to call it the graphing / vertex form. So we have y equals a x minus h squared plus k. And we know it's going to be a parabola. Make sure our phones are put away, please. And we know that it's going to be a parabola because what's our highest degree? Yeah, it's squared, right? So we know it's going to be a parabola, so we know it's going to be a nice little U-shaped. And if we go through all the conversations we've had with the parabolas, we know it's like U-shaped, it's like symmetric on each side. Then that point of where that directional change is that vertex, right? And then our x part, or our x coordinate, there you go, sorry about that. And my x coordinate is going to give me my line of symmetry on there. So in our cute little form that they give us, our A, that's going to be like that stretch or that compression that we had. So this is either a stretch or a compression. And you guys worked on these last week to where if that was a number greater than 1, it stretched it. Remember, you got their whatever factor faster. So if there was a 2 out front or a 4.5 out front, you're getting there like 4.5 times faster. So it made it skinnier. And if it was a fraction or a number between 0 and 1, it would make it fat, or it would compress it or push it out because you would only be traveling like at half the speed. So of course it's going to take you longer to get there. And then our HK, that's going to give us our vertex. And then if we know what our vertex is, and we kind of know what our compression or our stretch is going to be, we can make a pretty rough estimate guess on what that's going to look like. Biggest mistake that we make on these a little bit is figuring out our h, because in the formula it is x minus h, and we only need the h value. So it's almost like the opposite sign because of that negative. Yep.
The stress compression, is that, do we have to use that for anything, or use that for
Right now we're just going to use it like, you know, this would have been x squared. So then if it was 2x squared, it's going to be skinnier, right? When we get into it a little bit more, then we'll be able to kind of like plot to where we kind of get more exact. But right now it's just kind of, right, a rough sketch. Okay. So let's say for poops and giggles, we were given y equals 2 times x minus 3 plus 1. Do I have to remind you yet again to put your phone away? So if we want to graph this in our head, we know it's going to be a U-shaped. Whoops, I forgot the square. We know it's going to be a U-shaped. Is my U-shape going to open up or is it going to open down? It's going to open up, right? Because our number out front is positive, so we know it's going to open up. So if we can figure out our vertex, we'll know where that turning point is, and we know it's going to be symmetric on each side, and we can kind of graph it. So my vertex is the point HK. What do you think my H is going to be? 3, right? Because my formula is A times X minus H squared plus K. So what's my H? It's just the 3. And what's my K? 1. So 1, 2, 3, up 1. So that's my vertex. So I know the one side I'm going to come down, the other side I'm going to go up. And because it's squared, I just know that I just got to make it kind of a little more skinnier than what I normally would. So I got a whole slew of them for you guys to kind of work on a little bit. You ready for the next one? Let's say we had y equals negative x minus 7 squared plus 6. So we're in that graphing vertex form. So let's see if we can find out our vertex. Yeah, so our vertex is HK. So our H is going to be, yep, K is going to be 6. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Right? So there's my vertex. Am I going to open up or open down? Yep, and why am I going to open down? You got that negative out front. Am I going to like stretch it or compress it any? No, because it's like a -1, right? So it's going to be kind of just like a regular quadratic, whoops. Sometimes you make your dots bigger in life. And you just have to draw better than I do. Not too shabs? All right. That's all right. What if we had y equals x plus 9 squared? Yeah. Whoops. Can't spell today either. Vertex, right? So what's my vertex going to be on this one? Positive 9 or negative 9? Negative, yeah.
Because there's the plus sign instead of this.
Right, isn't this my formula?
Yep.
So if I just put in a 9 for h, I'd have x minus 9 squared plus k.
So why aren't the other ones, see it's x minus 7, so doesn't it make sense for it to be -7 6? But then why is it just the opposite of the formula?
Yeah, because of the negative. Yep. It's just like because, whoop, or,
It's positive 9, it's -9, it's -9, it's positive.
right, yep, because of the formula. So just like on the one up above, like your h is positive, right? Because this part here is the only part that's your h. So if you go by your formula, y equals a x minus h squared plus k, my h is 7. So x minus, what was it? 7 squared. So it doesn't change it.
So, but if it's jump for a positive 7.
Yep. So y equals a x minus h squared plus k. Y equals a x minus a negative 9 squared plus k. Right? Then you're going to get a x plus 9 squared. Does that make sense? Yeah. All right. So our vertex on this one's going to be negative 9, and what's my k?
0.
Look at you go. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9-ish. So right about there. Open up or open down? It's going to open up, right? And it's not compressed or stretched.
So if the number in front of the parentheses is like 8,
Right, yep. This number here? Yep. So if it's last week, remember if it was greater than 1, it's going to stretch it because it's going to get there faster, so it's going to make it skinnier.
so like how you don't have much, or is it just like this one?
For right now, we're just going to eyeball it, and then we'll figure out, because you can actually use it as almost like a slope to figure out the next point on either side of the vertex, but that's coming in a couple days. I know. Baby steps, right? All right, I got one more for you. What if we had, whoops, y equals x squared plus 7?
But it's still going to be the 7.
All right.
7 0.
Well,
But it's not
Well, it's not in the
parentheses.
right.
It doesn't mean the same thing.
Could you rewrite this as y equals like x plus 0 squared plus
It's the same thing.
7?
Oh no, because then you're putting this 0.
But those ones would be this.
So we're looking at it as you're missing
Yeah.
middle piece, but you're actually just have it's just
Not there.
Right.
It's gonna be
Yep.
0 and 7.
Yep. Because your x coordinate.
the 0 to the second will always be 0, so you're not adding something.
Right. You're right. Exactly. So the part that is being squared, right? That's your h. So that gives you that x coordinate. And then the part that's not squared is your k.
7's actually
Yes. So your x is going to be 0, and your k is going to be 7. Yep. So 0, 7, 1, 2, 3, 4, 5, 6, 7. And is it going to open up or open down? It's going to open up, right? Not too bad. Yeah, it just takes a little practice, right? All right. So we might as well, since it's not too bad, let's spice it up a little bit. It's no.
Okay, I changed my mind.
Changed my mind, right?
I'm not gonna.
So the other form that they can give you guys your quadratics in is the standard form. And your standard form is pretty much just where, well, we'll just write it out. Y equals ax squared plus bx plus c. So this is kind of the form that we're kind of used to seeing quadratics written as. So like for example, you could have y equals 2x squared plus 4x minus 30. So that would be your standard form. So then now if we wanted to graph this one, because we can't use our calculator, because it would be nice if we could just plug it into our calculator, but we can't put it into our calculator. That leading number, that 2, that's still going to tell you like if it compresses or stretches or if it flips. So on this one, it's just going to make it skinnier, right, by a factor of 2. When it comes to us graphing these, oh, pooey. We can find out where they cross over our x-axes. And remember how our quadratics are always symmetric, right? So for this one, for example, if I know where I cross here and I cross here, because of it being symmetric, I just have to find the middle of that, or the average, and then that's going to tell me where my vertex is. So when they don't give it to us in vertex form and they give it to us in standard form, if we find where it crosses the x-axis, then we can find our vertex. And when we cross the x-axis, what's our y value? Isn't y equals 0? So we get to do some factoring. So 0 equals 2x squared plus 4x minus 30. You want to factor the 2 out to make it easier?
I like bigger form better.
Without factoring it, that's fine. Oop. So if we do our little x box, right? A times c and b. A times c is what, negative 60? B is 4. So we got to multiply to get negative 60 with a difference of 4. So 10 times negative 6. So if we put that in our little box, yeah, what? 2x squared. Now we got 10x minus 6x and negative 30. Factor out our like terms. So we get 2x, 10, 2x and negative 6. So that factored into 2x plus 10, 2x minus 6, that equals 0. 0 product property says that one of these two has to equal 0. So either 2x plus 10 has to equal 0, or 2x minus 6 equals 0. 2x equals negative 10, x equals negative 5, 2x equals 6, and x equals 3. So this is going to tell me where I cross the x-axis. And where do I cross the x-axis? When x is 3 and when x is negative 5. 1, 2, 3, 4, 5. So since I know where they cross the x-axis, and I know my parabolas have to be symmetric, so my vertex is in the middle of those two. So how am I going to figure out the middle? I'm going to do negative 5 plus 3 divided by 2. I'm finding the average, right? That would be the middle. So it's at negative 2 over 2. So when x is negative 1. Okay. So somewhere here, whoops, I'm a dork. Somewhere in here where x is negative 1 is going to be my vertex. So I know this is my x, so I just got to plug it in to figure out what my y is. Right? Y equals 2x squared plus 4x minus 30. So y equals 2 times negative 1 squared plus 4 times negative 1 minus 30. Y equals 2 minus 4 minus 30. y is going to equal -2 minus 30, y equals -32. So we're just gonna, right? So way down here somewhere, right? And it's gonna look like that.